I just want to congratulate Bill on his fine collection of cephalopods that he had for his presentation. I don't think I've seen a finer set in my life, is the honest truth. But okay, thank you for bearing with us. I appreciate I am in the last slot of the day and I am all that stands between you and the reception. So I will try and finish on time, but we'll see how we go. So who am I? My name is James Page. I'm a principal engineer at Canonical. I work as the technical architect for the OpenStack, Ceph and OVN teams at Canonical. And I've been with the company since 2010, so quite a long time now. But chatting to some of the IBMers here, apparently not as long as people as IBM, but there we go. So I don't think I've had the opportunity to do that at Canonical. So before I tell you what Sunbeam is, I want to tell you why we're doing Sunbeam. And this is actually a little bit of history of my involvement in open source since I joined Canonical. So back in 2010, I joined the Ubuntu server team and I worked on a cloud platform called Eucalyptus. Does anybody remember Eucalyptus? Excellent, yeah. I had a Java background. No one at Canonical knew anything about Java, so apparently some Java expertise was needed. And within my first 6 months, we ditched Eucalyptus and went with OpenStack. And Sage uploaded something called Ceph to Debian. We kind of had a rethink about cloud strategy and made a complete pivot to a different approach on what we were doing. And that really began my involvement both in the Ceph project and in the OpenStack project. So we needed a way to be able to deploy and test and operate our Ceph and OpenStack tools. These were all part of the Ubuntu distro by this point in time. And alongside this, one of my colleagues at Canonical had started a project called Ensemble, which got renamed to Juju. And Juju, which Luciano kindly described for me earlier, is an application modeling tool that supports deployment and operations of the various components that you need to deploy a kind of distributed complex system like Ceph or OpenStack. So it fitted really nicely conceptually. However, we needed to do it on bare metal. So MAS was born, Metal as a Service. And we needed to put all these API services that OpenStack kept inventing into containers so they didn't all interfere with each other and we can manage and scale those things independently. The LXC project grew something called LXD, and that kind of fitted nicely in terms of compartmentalizing all of those different components and being able to produce a very maintainable and scalable deployment of OpenStack, including Ceph. We wrapped that all in a set of charms, and that's the OpenStack Charms project upstream under the Open Infrastructure Foundation. I can't quite remember when that went upstream, but it was a long time ago now, and that's been an absolutely proven solution for deployment of OpenStack and Ceph, both together and independently, actually, over the last decade and a half. But was it a one-size-fits-all? We had great adoption in 10 nodes and up, basically. Anything up to sort of 600-700 nodes works fine, probably even further, is the honest truth. And I know there's some pretty large deployments out there that I don't know about. But the overhead of MAS, the overhead of the tooling, it fitted very well into a very large data center deployment. So what we would find with a Ceph deployment or a private cloud deployment based on OpenStack. But where we really struggled was making it smaller, right? The overhead of all these things meant that we couldn't squeeze it down onto much smaller devices. So edges such as base stations and telco towers or very small appliances or factory units were really beyond us in terms of what we could target. So we had a little go at that with something called MicroStack, and that was OpenStack in a snap. Can I have a show of hands who knows what a snap is? Okay, I'll do a brief explanation then. So a snap, it's a packaging distribution format. It has very strong security semantics around it, so it's kind of sandboxed like a container, but it's much more integrated with the base operating system compared to what you might expect to find with a container. So we put OpenStack in a snap. So you could install OpenStack, it would bootstrap everything, and you get a running cloud on 1 to 3 machines with the idea. But there were some quite key challenges with that, because although we shared OpenStack and Ubuntu as common components, the rest of the technology set was just completely different. We had snaps. And we had all these great operational semantics in the form of charms and what Juju was providing us with. And we only had this very small intersection, and we were only a very small engineering team. So we actually kind of put MicroStack to one side and said that's not something we're going to go forward at this point in time. We need to kind of rethink that strategy a little bit longer term. So alongside this story, there's a whole load of other stuff going on in the ecosystem around us, technology-wise. So has everybody heard of Kubernetes? Yeah, okay. I probably don't need to explain what that is then. But Kubernetes appeared, became very, very popular as a new way of managing your workloads in a very scalable, automatic way in terms of fault tolerance, auto-scaling, all that type of stuff. Juju grew support for actually targeting Kubernetes as a substrate. So we didn't just have to do things with machines, we could do things with application containers now as well. And there's a whole heap of OpenStack that fits really, really well into an application container and is a perfect candidate for running on top of Kubernetes. So we had a bit of a rethink, and that's really what Sunbeam is about. So Sunbeam is a complete reboot of how we think about deployment of OpenStack and indirectly Ceph, which is why I'm talking about it today. Which allows me to go forward and explain exactly what Sunbeam is. So it's a project that's incubating under the guidance of the OpenStack Technical Committee under the Open Infrastructure Foundation. And our objective is to enable deployment and operation of an OpenStack at any scale. So from a VM running on your laptop all the way up to a many thousand node deployment across multiple data centers. We're leveraging a hybrid deployment approach. The engine is Juju, but that's not typically what's exposed to the end user. We're using Kubernetes components and we're using machine-based components. So we haven't tried to push everything one way or the other. We've kind of taken a best of both worlds approach in terms of what needs to go on a machine, things like Ceph and hypervisors and stuff there, where you would have to poke lots and lots of holes through the various Kubernetes layers to make that work really well. We've taken a snap-based approach to that deployment, which allows us to integrate much more closely with the underlying operating system. But the stuff that works really well on Kubernetes, like all of the control plane, the messaging, the database, that is all Kubernetes charms being targeted to the Kubernetes platform. So we've taken Sunbeam and we've rebaked MicroStack based on Sunbeam rather than the original pure snap-based approach that we've got. And that's what you can try today. If you search for MicroStack, that's the Sunbeam-based implementation that you will find. So kind of brief architectural overview. We pack everything in. You start with a snap, that integrates with Juju, and we then deploy a set of Kubernetes cluster directly on the bare metal. And then alongside that, we put compute components down, we put Ceph down, and I'll talk about how in a second, and we put the various networking components down as well, and then we deploy the control plane on top of the Kubernetes cluster. And then we can use the concept of a relation in Juju. A relation happens between two charms. We can do that both within the Kubernetes model, but we can also do that on the machine model as well, and between them. So we can relate things and configure machine-based payload with configuration that's coming from the Kubernetes deploy components, right? Right, so this is broadly what a deployment looks like. So as I said, you install the snap. This is a local mode deployment rather than a MAS mode deployment. You prep the node for deployment, and then you can bootstrap this node as the first seed node in your deployment. You'll notice that we have a role storage, and that's really where Ceph hooks into our story. So that process of bootstrapping the cluster, it puts Juju down on the machine, it puts the Kubernetes deployment down on the machine, and we're using MicroCeph at the moment. It then puts MicroCeph down on that, which is what I'm going to talk about next. So I think Luciano talks a little bit about MicroCeph in his NVMe over Fabric talk. But MicroCeph, from Sunbeam's perspective, is Ceph in a snap managed by a charm, right? So there's a lot of control logic and functionality that's in the snap that you can use outside of the charm context. But because we're using Juju as the engine for everything we want to deploy, we use the MicroCeph charm that sits around that to then help drive and integrate that into the rest of the solution. So Cinder that wants to talk to Ceph, and Glance that wants to talk to Ceph, and the hypervisors that also need to have credentials and stuff like that, they all relate to MicroCeph through its charm interface rather than directly to the snap. So about the snap, is basically Ceph in a snap. It's isolated, it's very upgrade friendly, and it's quite transactional. Who's upgraded Ceph on a deb-based installation before? Anybody done that? Yeah. How many packages? Quite a lot, yeah. Especially if you're going between Ubuntu releases as well. With the snap, all of those things are baked into, they still come from the deb source in Ubuntu. So we're taking that kind of heritage of bits from Ubuntu, but we're baking them into a snap, which is basically a point-in-time image of all of those components. So it means that when you upgrade your snap, it's very transactional. We download the new one, we stop the services, we switch the pointer, and we restart the services. So it's a much more instantaneous upgrade experience compared to what you might have experienced with debs. With MicroCeph specifically, we also have some coordination ability there. So we know that actually upgrading all your OSDs in your cloud at one point in time is probably not a great idea. That needs to be a rolling affair so that you can do each node at a time. And MicroCeph, through the functionality the snap provides around Ceph, is able to coordinate and orchestrate that for us. So if you're going through that upgrade process, then that's more of a rolling approach rather than you having to coordinate that all yourself. As I said, it's containerized. Snaps have this concept of interfaces, and that's how they access privileged components within the host operating system. So for Ceph, it needs to be able to advertise networking services. It needs to be able to talk to storage, obviously, and it needs to do a load of other things about like NUMA node topology discovery and all that sort of good stuff. So anything that's interrogating the host operating system is done through a very confined interface that allows it to do what it needs to do and nothing else, right? So if we have an exploit into Ceph, God forbid, then we've got very much a sandboxed approach on how we're deploying it, which gives us some additional security guarantees, which is great. We have some nice distribution semantics. We can express risk levels for the version of MicroCeph you're having, and we can switch you between releases as well. So you'll find tracks for Reef, you will find tracks for Squid soon, I hope. We're getting there. I think we're working on getting the RC through this route at the moment. But fundamentally, it's still Ceph under the hood. It's like, we're not changing the bits, we're just distributing it in a slightly different way and giving you some different operational semantics on how that's going to work. So as I said, we're using the MicroCeph charm in Sunbeam. That basically gets us started. It installs and bootstraps and forms the MicroCeph cluster, which then forms the cluster of monitors and managers and all the other bits and pieces that hang together. It gives us the interface for adding and removing storage devices, which Sunbeam kind of orchestrates as part of its deployment approach. And it allows us to integrate with other parts of Sunbeam through the relations it provides. So that includes Cinder and Nova Compute, as I mentioned. MicroCeph also provides Raiders Gateway as one of the services it can provide, and we're using that feature as well. So we basically enable Raiders Gateway on a set of the nodes. It could be all of the nodes depending on the size of your deployment. It could be a subset of the nodes you have in your deployment. And then we actually expose that through Kubernetes. So we use a load balancer that's hosted in the Kubernetes control plane, and then we can leverage a lot of the network capabilities that Kubernetes is providing us to do much more intelligent network integrated load balancing. So we can do the classic kind of L2 virtual IP type stuff, but we can also do ECMP integrated into a BGP network fabric, for example, which gives us a much broader range of things and network topologies that we can address with Sunbeam and MicroCeph together longer term. I can't remember what my next slide is. Okay, so what does that look like this is kind of a snap view of the world. As I said, we have a local mode. So that's the idea is that local mode is targeting smaller deployments. So that single node, probably up to the point where you get bored installing Ubuntu is the honest truth, because we don't install Ubuntu in local mode. It's assumed that you have installed and configured the machines how you want, and now you're installing OpenStack on top of that. But we also support deployment using MAS, as Charmed OpenStack does. So that's where you're getting a full data center automation, which is deploying and provisioning and configuring your machines, and then handing those off to Sunbeam to integrate and deploy components on using Juju and the charms that form the Sunbeam charm set. We've taken a slightly different approach to that compared to the OpenStack charms in that we make, if you're familiar with MAS at all, we make a lot of use of tags to express the intent as to what a machine should be used for, but also what the devices in the machine should be used for as well. So should they be Ceph, what network interfaces should be used for what purposes, how does that integrate to Neutron. So we've leveraged existing tooling as much as possible to make a very expressive and well-documented and obvious experience on how to deploy all these different components. Where was I going? Right, so a summary. I'm nearly at the end. Summary is like we've produced, in Sunbeam we've produced a solution that has fast and much more reproducible deployments and operations. Pretty much everything we're doing is image-centric now. So when we don't get hit by archive drift or new updates appearing. The version that we test with in product engineering is the version that the customer will use until they decide to move forward with a track or a version. We've got much better and improved security for all of our bare metal components through snap packaging. What we found is that because we're getting much more from the substrate and through of Kubernetes through Juju, actually the charms that we're producing for all of our OpenStack components are much simpler, right? They don't have to worry about how do I HA myself and how do people access me, because that's all provided by the Kubernetes substrate, rather than having to be directly baked into the charms as we had to do in the OpenStack charms for machine charms. So we've got simpler, much more maintainable software. We've taken the tooling up a level compared to charmed OpenStack. So if you've ever tried charmed OpenStack, we really gave you a toolbox which had a lot of bolts and bits of metal in it and some screwdrivers and pliers and maybe a jigsaw if you were lucky. And that was a solution you could form into something in many, many different ways, right? So the Ceph components and the OpenStack components, although individually opinionated, could be composed in a multitude of different ways, which could get users into a multitude of different troubles at the end of the day. So the approach we've taken with Sunbeam is we've taken it up a level. We've produced something that is very, very opinionated and will guide the user much more. So we've reduced that cliff face of knowledge that someone has to climb before they can even get started. That said, once you've gained that knowledge and you've become comfortable with the solution, it's still all the same components under the hood. So you can pop the hood, you can have a look at what's going on. We've ensured that the observability and transparency of the solution is still there, so that you can drop down and dig into the details of exactly what's going on. So where is Ceph broken? You can go, of course Ceph never breaks, but through MicroCeph you can go and interrogate the status of the OSDs. You can look at the status of the Mon cluster, and that's bubbled up into the Juju charms that are encapsulating those components as well. So we've produced something that's much more opinionated and on rails, but also very flexible still. So, but flexible in very defined ways rather than in any way you would want to do it at the end of the day. The other thing is we've been able to enable a kind of whole load of optional features on top of this and integrate with a whole load of other solutions out there. So we have features in the Sunbeam tooling for enabling observability as a first class thing. So that integrates Grafana, Prometheus, Loki stack into all the components that have been deployed. So the OpenStack side and the Ceph side, it doesn't matter what it is, we're just integrating that in a very standardized way. We've plugged in validation tools, so it's very easy to, once you've deployed your solution, to actually validate it's functional. So we can run the upstream Tempest test suite, maybe CBT in the future as well, so that we can actually look at the performance of a deployment. And we've kind of used all the micros. That's one I've missed here. So we've got MicroStack, and we're using MicroCates and a bit of MicroCeph, and we use something called MicroCluster that underpins most of those projects as well, which is a kind of Raft-based equal-like distributed state store that we use for a little bit of coordination on the back end. The one thing I haven't put on here is when can you get all this great stuff? So we've been incubating for, I don't know, probably 18 months now. We are getting to the point where we're working towards our first true LTS stable release this year. That will be based on OpenStack Canonical and Ceph Squid when we get it. And I would anticipate that coming in probably towards the end of the summer. Once we've got all the various bits and pieces lined up, we're going through a stabilization process at the moment where we're tying everything down as to what the manifest of software will look like for our actual release. And ironing out any kind of final bugs and general issues as we go through that process. We expect to achieve full feature parity with everything that charmed OpenStack can do probably in the first or second quarter of next year. We have a whole load of kind of enhanced platform awareness stuff that we know we don't do in Sunbeam yet, that we need to work into the solution so that we can we can effectively provide a migration target for charmed OpenStack deployments at some point in time in the future. Okay, almost on time. Have I got time for questions?
Of course you have.
Excellent, great. Anybody got any questions?
Yeah, just a quick one. So is the plan for Sunbeam to basically replace the default charmed OpenStack deployments?
Yeah, that's right. So for charmed OpenStack, the Canonical release is our last OpenStack release. There won't be any new OpenStack releases on charmed OpenStack. I like to think of Sunbeam as the child of charmed OpenStack. So, you know, we've taken a lot of the learning that we had from that body of work into Sunbeam, and we will provide a migration path probably towards the end of next year for anybody who's deployed on charmed OpenStack to be able to migrate to a Sunbeam-based deployment. So,
cool. Thank you.
Do you foresee a way for admins to inhale a non-charmed Ceph deployment into Sunbeam?
Oh, that's a good question. I can think of some ways to do it. Essentially, we need to deal with migrations as part of that migration from charmed OpenStack and the charmed Ceph that encapsulates to MicroCeph and Sunbeam anyway. So we would definitely probably to have the kind of targets and hooks in place to do that. And I know we have done kind of PS type work around that in terms of migrating from other vendors' Cephs to our own Ceph in the past. So it's definitely possible. There would be some detail to work out, definitely. So
thank you.
Great.
Excellent.
Thank you very much, James.